Hello, good afternoon, good morning, wherever you are in the world. Good to see you all, and thanks for taking the time to join us. And welcome to the second session of the webinar of Reaching New Target Depths, a MechLOK and Icon collaboration between ourselves at Deep Casing Tools and our friends across the North Sea in Norway, NOV Completions. I will start by introducing myself. My name is Eoin Wood. I am the Global Sales Manager here at Deep Casing Tools, and I have been here almost 2 years, having spent the previous 11 years with Innovex Rubicon, to give them some of their previous names. And I will pass over to my colleague across the North Sea, Kim.
Yeah, the chilly part of North Sea here in Stavanger.
I don't know today.
Oh, it's cold, I tell you that. Kim Mathisen, I work with NOV Completion Tools with business development. Been with the company for almost 8 years. We call it my baby. There's Icon drill pipe logging tool. And before that, I have run lower completions liners with Halliburton. So I have my fair bit of experience in similar application like this ones. Yeah, looking forward to it.
Awesome. Well, thank you, Kim. We just came off the back of some very interesting client visits in Norway last week, so we're very fresh and well practiced in our presenting skills. So, yeah. So how this is going to work? We'll give you a bit of background on the project, and we have 3 wells to show you, each well using a different MechLOK Drill Pipe Swivel, and each well be run with the NOV Icon data recording sub. So very much collaboration is order of the day here. So what I'll do to begin with, we're going to give you some background in both tools. We're going to keep it short and sweet. Our MechLOK tool is relatively new to the market. It's been on there for about coming up for 3 years now, and just a way to do its 30-second run globally. Now, just to give you some frame of reference there, 11 of those runs have been in Norway, and 14 of the 32 runs have been on multilateral wells. So we've got pretty good experience on multilaterals already. Now, our MechLOK tool, many people are familiar with one of our competitors' tools, which has been on the market for a long time and was very much a single source for a while. Now, that tool was hydraulically locked. So a swivel, as you may know, allows you to rotate the drill pipe independently above the completion or lower liner, while keeping the completion itself stationary, giving you more available weight to push the completion to TD. Now, with hydraulic activated tools, you would drop a ball, the tool would shear and essentially become a puck joint. So we decided to make something a bit simpler, a bit easier, and the MechLOK was created. Now, the MechLOK is 100% mechanically locking. There's no shear pins, there's no hydraulic mechanism in this tool. So the operator selects when this tool locks. It doesn't have to lock during the packer or hanger setting procedure. And we have 4 variations, all mechanical. And our thinking has been, we've developed these alongside our customers. We've listened to what they've required, and it's not a case of getting something off the shelf to fit their requirements. So this is just a look at 2 of our standard 5.5-inch tools, very chunky, robust tools. You get a small glimpse of the locking mechanism, which is largely similar across most of the variations. You've got locking key slots there and a locking nut, which contain locking dogs. And when the locking dogs marry up with the key slots, that's when the tool is locked. And you can imagine when we do rotate, this locking nut will move along the thread and the dogs are going to go into these key slots. But we'll go more into the specifics of each swivel type when we look at the individual wells. Now I'm going to get past to Kim to give you a little background on the Icon sub. You with us, Kim?
Thank you. I was muted there for a second.
Sorry, there we are.
So the Icon, it's a drill pipe mounted memory logging tool. So what you get on it, go straight to the point. It's axial loads, tension, compression, torque, temperature, inside and outside pressure. So the tool is 3 meters long. It's designed to be more robust as a drill pipe, so it shouldn't create any bottlenecks or limitations, to limitations. And, it logs data for 36 days. So it's really easy to send out without any need of dedicated people to run it. And, one of the big reasons for using it is actually when trialing new equipment. And historically, why we designed this tool, that's part of the NOV tool portfolio, was to have more data for running liners and lower completions, which historically has been, one of the biggest pieces of NPT causing issues here in our industry. So, by making these operations, liner hangers, lower completions more robust, by having downhole data and also tools like drill pipe swivel, is two of the actions which definitely can help the operators for reducing these NPT and making more robust and efficient plans on these projects, on new projects.
Awesome.
So a little bit on the application and track record for a logging tool. So the drill pipe swivel is still fairly new. The Icon monitoring sub, that's quite the opposite. We have 160 runs globally as well. And you see some of the applications here as well. So in essential, it can be all drill pipe mounted runs, but the main applications are lower completions liners. You can see a little bit on where we have run it. We started out as a company in the North Sea, minor Norwegian company, before eventually NOV purchased the company in 2016. And after that, of course, the global footprint with the amount of jobs done, of course, increased significantly. So we see some of the projects have been with the established operators like Total in Africa for field developments. We have written a SB paper there as well. So, yeah.
Awesome. All right. Yeah, so just before we jump in, just a little background on the partnership between Deep Casing Tools and NOV Completion. So, obviously, Deep Casing Tools are a relatively small downhole technology tools company based out here in Aberdeen, Scotland, and our partners exclusively for the Norwegian market are NOV Completions. And as you'll see over the next sort of half an hour, our collaboration is extremely valuable. What it's brought to both sides, I think, it's paid off for both of us, and we've done some fantastic work over the last 18 months to 2 years with the MechLOK and with the Icon. Now, this is a typical trilateral well that we've been tackling over the Norwegian North Sea. Now, as you can see, there's a lot of pretty fancy jewellery in there. These wells are long, horizontal. They are completed with sand screens, and they more often than not require the aid of a swivel to reach TD. Now, one of the main advantages of the MechLOK tool is the ability to reset and rerun our tool. So you'll see the theme as we go through the 3 examples that our tool was run in each leg of the trilateral. So we're running the tool 3 times on each run without a full redress, and it can be reset and rerun on the rig. So it's very simple, and all the loads, all the rotation, all the weight that our tool has seen is all recorded brilliantly with downhole data. Now, before we go on to the well, Kim, anything you like to say about the work we've done?
Yeah, so yeah, it's been a journey. You know, we will go to 3 wells here, but also and you said, you know, it's been good for us NOV and you guys DCT. But let's also at this stage mention it's been really good for the operator and the whole project's execution team as well. They have learned a lot, not only about our tools, how they work, but also what's happening in their wells. And you mentioned it a little bit, you know, MechLOK is adding a lot of functionality in the well, but let's also think about the functionality it adds outside of the well, where you have simple logistic. You know, you can rerun the same tool on several runs in one well. Most of the runs is not reset. We'll come back to that, or locked. So, you know, it can be run directly after. No need for sending tools back onshore. So no, it's adding value in the well and outside the well, I would say.
Yeah, very, very good point. Okay, we'll get on to the first of the trilateral wells now. So this was approximately 2 years ago now. Seems like time just flies when you're having fun. So this was our MechLOK L tool. Now the original MechLOK tool was in compression, was a swivel both ways. So in compression you can rotate the drill pipe and you will not transmit torque to your lower completion. To lock the standard tool, it was 25 right-hand turns of the tool in tension, and that locked the tool. Now, this customer in Norway got in touch with us and wanted a very nice, simple tool that would lock to the left in tension, which would allow them to activate any mechanical emergency release mechanisms they had. Now, we ran with the icon in all 3 branches of the trilateral, and the same single tool was run in all 3 branches. So it was ran 3 times and passed MPI inspection on return to town. And all 3 laterals were successfully deployed to TD. The first well we did was very much a trial well. I don't think the trajectories were as challenging as wells 2 and 3, but we still got some absolutely fantastic data back. So yeah, let's, in the meantime, Emma, our marketing coordinator, is going to put a poll up. Now, if you look on the left-hand side of your screen, there's a tab that says poll. So Emma's going to put this up. Please cast your vote in the poll, and we'll look at the results and discuss after we've analysed the first well in question. Please also, if you have any questions, please feel free to put them in the Q&A tab on the left side of your screen, and we will deal with all questions at the end of the webinar. Okay, so this is very much your territory, Kim. I will pass over to you.
Yeah, it's my territory, and I think it's good for the audience just to get used to this format, because this will be the same for all 3 wells. We're starting on the first one, G09. So typically after we have done this downhole data jobs, we go to the operator, ask them for the rig data. We put the rig data in one big file with the downhole data, and then we put them in our plotting software, and we make analyses like this. So let's see what we have here. You know, the objective for the first well, right? It's a trial run for the MechLOK. So we wanted to check that the swivel tool is doing what's it intended to do, swivel. And we also wanted to check that the tool is locking on an operator well, right? So on the left side, we are focusing on the swiveling part. So at the very left of this graph, you will see the bit depth. So right, we are down at we are at TD at 3,405 meters, and we are running down the very last stand. Before we do that, we pick up, and we can go all the way up here at the orange. We will see your hook load. So first we pick up, and then straight below we have the icon weight. And the icon weight, we didn't mention it, we put the logging tool directly under the MechLOK swivel. The reason for it is, to prove when we are doing rotation, to not have any, hopefully, torque below on our completion jewelry. So first we pick up, you see that the icon is in tension. How do we see it? Well, we have a horizontal neutral line, which kind of shows neutral axial load on icon and MechLOK. And before we swivel it, this version, we have to put it in compression. So, we set down our weight, and we have 8.5 ton metric compression at the tool. So once we have done that, we start our surface rotation. We gear up to 20,000 Newton meter at surface. And then we are having 40 RPM here at the surface. And then we check in the middle here, we see that the pink graph, that's the icon torque or below MechLOK torque. Sorry for that with the light, by the way. That's 0, just as we wanted. It's 0 before we rotate, it's 0 when we rotate, just as we're doing. And then, after we start that, we go down with the stand. So swiveling achieved, and go back a little bit also and showing the weights there. So then we also are quantifying the hook gain, kind of the effect by this friction reducing tool. So now we go back to our planning torque and drags, So that's another benefit of having downhole data here. So that's the first part, accomplished. If we go to the right part of the screen, we are locking the screen. Then we need to pick up the string. So then we pick it up. We have 11 ton metric in tension, again at MechLOK. Once we have done that, we start our left-hand rotation. And you see, while we are rotating these 25 turns, we have minus 1,000, almost 500 Newton meters at the tool. And this is just torques building up at the tool. Again, 25 rotation. And then the next question is, how do we see that it locks? Well, that's at the very end. We have this torque spike here, quite significantly here on this job. And, I used to say that, a blind man can see that we are locking these tools. It's quite easy to see that we are locking the tools.
Awesome. No, sorry.
Yeah, first job done.
First job done. Now that's the same for any swivel. The only indicator you're locked there is torque. You're either rotating the drill pipe or you're rotating everything. And here we've been very quick, set the torque limiter, and that means we don't put any significant torque through to the lower completion. So for our first run with this customer in Norway, I think a fantastic result, proved the functionality. I mean, this downhole data is hugely valuable to us, the NOV, and to the operator.
Yeah, and also we can just mention shortly from this job that, have a little note about the time we use to lock the swivel, So I guess a lot of the guys, girls here on the phone have been, dropping balls, starts, hoping, waiting, praying that these will land and work as intended. And that can take, from 10 minutes, depending on the well. Is it a deep well? It can take, 1 or 2 hours, right? Here we are talking 1 or 2 minutes.
Perfect. Okay, just before we look at well number 2, Emma, do you want to share the results of the poll with us?
Yeah, thanks, Ian. So I can confirm that those who answered the poll question answered yes.
Fantastic. As we'd hoped. So yeah, downhole data would be useful when running screens into a long horizontal well. And yes, we agree, and yes, we hope to prove that to you as we go on even further. So we will move on to well number 2. This happened just over a year ago, I believe. I lose track of time. So this one was a bit more challenging, and the customer approached us. Well, we approached the customer. We had a discussion, and we asked them what they would like to see improvements or changes, and we looked at producing a tool. So this particular operator had issues in another asset with residual left-hand torque building up through the completion and releasing their running tool early, which is obviously a bit of a disaster for an operator in a long horizontal well. So we also wanted ourselves to create a swivel that was capable of swiveling in tension and compression. So the MechLOK T was born, T standing for tension. So this tool is always a swivel to the right in tension and compression. And to lock this tool, you pick up into tension, you start to rotate to the left. You need to slack off some weight when you're doing this. That engages a collet and allows you to lock the tool. So it's almost impossible to lock this accidentally, which is obviously a very, very nice feature. Once again, the same single tool was run in all three legs of the trilateral, and all three legs were landed at TD. All three legs had an icon made up with a swivel. Kim, anything from you before we get on to the next graph?
Yeah. So as you are seeing now, this is the MechLOK T instead of the MechLOK L. I can just mention a little bit that the tool comes in different configuration, but the base design is the same. It's more like we are adding kits on the original MechLOK. So, you know, the tool is, the heart of the tool is staying the same here, just to have cleared that up a little bit, yeah. And a lot of customers, when me and Ian are out presenting, you know, they are asking us, you know, you have a couple of different configuration. What's the best MechLOK? And it depends on the functionality you need. But in terms of straight out swiveling, MechLOK T is the tool to go. You know, as Ian said, it will swivel compression, neutral, tension, left, right, you know, until you lock it. And this is very hard to accidentally lock.
Nice one. Okay, so this one we're going to be concentrating on swiveling the final 4 joints of screen to depth, and we're also going to be focused on the locking of the MechLOK T and the mechanical release from the liner hanger running tool.
That's right. So we are 3,000 meters here, still at the same operator. So the well is G40, and we can start with the swiveling. Again, the operator, they wanted the same. They wanted to test that the tool is swiveling. They wanted to lock it, especially since this is a new configuration. So on the swiveling, if we go to the left here, you will see that they also are having the tool here in compression. That's, you know, no tension. That's when the blue line is above the black horizontal line here. And at the bottom, you see in the same kind of manner, we are having our rotation here. So we're having, you know, 40 RPM. We are having around 15,000 Newton meters right-hand torque on surface. And you see our tool, again, icon below MechLOK is measuring 0 just as we want. And during the first stand here, we are swiveling both in tension and compression. On the second stand, only in compression. So, you know, swiveling confirmed. Locking sequence. This one is a little bit different locking method, I would say. Still start with having the tool in tension. So we pick it up. And then when we have it in tension, we start our left-hand rotation at surface. You will see the green one. We go to around 10,000 Newton meter-ish, I would say. Once we have done that, we start going down with our hook a little bit. So you see on the icon weight, it goes from tension to compression. And in a similar way, we see we're building up these rotations at the tool. And then we have a torque increase clearly visible on surface when the tool is locked there. And yeah, you see it on the green there quite, you have a couple of thousand Newton meters increase there. So it's really easy to see that you have locked it. With icon data memory, the pink one, you see that we are around just hovering around 0 when we are building up torques. And when we are locking it straight out, the lower completion will see that torque. And again, lastly, you see the time there, a couple of minutes to lock the tool, and a couple of more minutes to mechanically release from the drop-off section of the liner, which is it's quite cool in in being an efficient run on saving operator rig time.
Definitely, and I think that kind of the focus for this customer as well was to potentially move away from the hydraulic release, move away from relying on balls landing on seat in very long horizontal wells, which is a very high risk for some operators. And I think this particular operator have had issues in the past. So in theory, we're looking to save this operator maybe 90 minutes rig time per release. Over a trilateral, that's, I guess 4.5 hours worth of rig time. And in today's market with the rig rates, it's a significant saving.
I guess they're looking at everything, as a lot of operators and us in the energy business, right? We want to be more efficient, save time. So right now they're using the conventional hydraulic release on a lot of wells. They want to benchmark and trial if mechanical release can help them be more efficient.
Yeah.
It's only one way kind of to find out, right? We have the tools to help them get there.
And quite an interesting thing about this tool as well, we've been doing some very interesting operations on this side of the North Sea, where we're actually running lower completion, and then we're going straight into a wellbore cleanup using the MechLOK T. The functionality being as such that it allows you to do this. You can swivel your completion to depth, hydraulically set and release, and then you go straight into a wellbore cleanup. Because as the MechLOK is unaffected by hydraulics, it will remain a swivel until the customer decides they want to lock out. Now, it's very much about selective locking. You don't have to lock out when you set the hanger or packer. And that's a very strong selling point on the MechLOK tool.
Yeah, and spot on. When we are coming to those discussions, when these technologies can help the operator to spare, make 2 trips into one, that's really very easy for all parties involved to see that this must be very efficient and interesting to consider, right? We had a similar one, I guess, on this project, where on several of the screen runs, we go down, install the screens, and when we pull out, we also, with the same trip, we are retrieving the whipstock instead of pulling out the foal and doing a separated trip for whipstock retrieval.
Nice one. So yeah, that takes us through the second well and the use of the MechLOK T. Now the final well of the 3. We again talked to the customer. We had a lot of collaborative learning sessions with them, and we decided to develop in conjunction again with this customer the MechLOK R. The R standing for ratchet or sprag, essentially. Now, on this tool, there is essentially no locking mechanism. It will always swivel to the right, and when you turn left, it will always rotate the entire string. So it's very good for quick mechanical releases. Now, this customer wanted a tool that was simple, still was robust, but would perhaps not require an offshore engineer to run due to POB constraints, which are very, very common around rigs around the world. Now, you'll see now that the amount of runs we did on this well was higher. So there was 5 runs. Now this well was a lot longer, a lot more challenging, and we actually had to initiate some screen drop-offs. So we ran the screens in 2 sections in a couple of the laterals due to the long length of the laterals themselves. We managed to deploy all 3 to TD once again, and we used the primary tool 3 times and the backup tool twice. So logistically, only 2 tools offshore compared to perhaps maybe 4 or 5 for a competitor tool. Yeah, before we jump in, Kim, as well, Emma's going to put up another poll for you guys, which we'll discuss after we analyse the data from this final well. So once again, look at your tab on the left for poll. Please cast your vote. And also, as I said before, any questions, please put them in the Q&A tab, and we'll address those at the end of the webinar. Yeah. So Kim, you anything to say before we move on?
Yeah. I always have a couple of things to add. So we, at this stage we have done 2 wells, 2 different tools, 6 runs, everything very successful. And after those 2 jobs, the customer TRL7 qualified this tool. So before we did with the 3rd version of the tool, we already have a kind of TRL7 qualified the tool. And again, it's a little bit about the journey to come here. We ask the customer after the well, it's long wells, it takes a long time to plan. How can we improve? And I guess in short, they were happy with the swiveling functionality, but they were asking for an even simpler tool to operate, and maybe doing, don't having need of a single operator from the service side. So helping them with POB issues, essentially. So that's part of also the background we designed this ratchet tool. And yeah, I don't think we can jump directly on the plot. Let's do it.
Let's do it, man. There's a lot going on here. I guess more of the focus here is, we verified the swiveling and locking functions of the MechLOK now with the downhole data. I think now this is more of a focus on us trying to do a mechanical release from the liner hanger running tool.
Yeah, spot on, and also to make some variation to the webinar, not so showing a 3rd tool and that we are able to swivel a tool. We have seen that on the previous tool. So again, we did that with the 5 runs here with the MechLOK R. We proved the swiveling, locking. Nothing to say about that. So the operator challenges themselves a little bit here, and they wanted with the MechLOK R to do a mechanical release with a new drop-off system, which I historically use hydraulic release on. And this was one of the longer laterals, deep ones. And this is a good plot which shows really the value of downhole data. So if you look at this, they ended up using 3 attempts of activating the left-hand release on this drop-off liner system. And you can kind of see that from 15, 30, 32 minutes. That's the 3 attempts. But kind of this is really where downhole data shows, because unluckily it's memory, because when you do these attempts and are not succeeding at first attempt, maybe you're this, and then you're a little bit more rough with surface torque, surface raise on second. When you don't succeed, you're kind of doing like this. I'm not sure whether you're doing on the 3rd attempt, but that's where we succeed. So let's jump directly into the first one, 15 minutes here. On this one, again, long horizontal, they are working with almost down weight. They are working with, let's say, 45 ton down, and they are working with 5,000 Newton meter left-hand torque, right? And obviously, they're not getting down. They needed 3,000 of those 5,000 to get down to the left-hand release tool to be able to release. And if you see straight on the answer here, we only got not even half of it downwards. We got 2,000. But very interesting, that's why didn't we get it down, right? What did we go wrong? And then if you see on the icon weight or MechLOK weight here at top here, we never touched the neutral line. The MechLOK and the left-hand release was always in tension. So we didn't work enough with the string, to allow the left-hand torque to come down. So skipping over to the second attempt, and I used to joke a little bit that, because I'm an old liner hanger guy, and we used to say all of these darn liner hanger jobs always come up at night shift, and I guess this one is just another one in that queue, right? So we start up here at around 145, 150, and now we are working with 29 ton on your hook instead of 45. So we are working with surface now a little bit more rough, 20 ton more approximately, and we are working with 6,700 Newton meter left hand torque. If you see downhole, we still are not getting too much down, but now you see the torque is fluctuating. So now definitely we have more momentum down. And if you go up on the weight, you see that while working with more down weight on surface, now we are getting compression at MechLOK and at the release tool, right? But however, we just got down to 2.4, we needed 3,000 Newton meters. So after a while, the second part of the second attempt, they increased the left-hand torque to 8,000 Newton meters left-hand. But at the same time, unfortunately, they decreased the hook load. Instead of working with 29,000, we go back to working at 45 ton at surface. So working with 20 ton less. And look what happened at MechLOK there. We are not transferring any weight down. You know, we are having 9 ton tension here. And that can also be replicated here. If you look at the downhole torque, we are not getting down any more of that nice 8,000 heavy torque. We are not getting it down at surface or downhole, sorry, except when we are pulling the string afterwards, because then we have, you know, worked up the string with a lot of torque, which all of a sudden will get this torque away quite fast. And that's what we're seeing, this little spike here. So then we have a 1 second spike, where we have almost 5,000 Newton meters left-hand torque. And then, of course, you know, we can ask the question, why didn't this tool release? And then, you know, it's a tool provider who needs to say that. But we can show that while we have enough torque in that little spike, just a few seconds, we also have the tool in tension. And on this operator, on this technology, they said that this tool should be in compression to actually be released at 3,000 Newton meter. It might release at intention, but then definitely we need more than 3,000. 5,000 should maybe be enough, but that's another story. So let's go on to the third attempt where we actually succeeded.
This one?
Yeah, let's just zoom it in. We have spoken about the other one. So again, this is showing the beauty of downhole data. So we have identified now prior, I used to call them red lights, yellow lights, you know, what didn't go wrong, why didn't we get down enough torque. So in the third attempt, we were working with the right amount of weight at surface and the right amount of torque downhole. So around 30 ton and around 8,000 Newton meter left hand. And look what's happened here is when the magic is happened. So by using the right surface input, then we are getting down the right torque in just a matter of minutes. So within 1 minute here, we see after 2.45 minutes after working, we get the 3,300 Newton meters left hand torque down. And then on this, you know, in the total, we ended up using 30 minutes here before it was released. But, you know, from a data point, we can ask the service provider, well, did your tool release after 2 minutes, or was it after 3 minutes? Or at the very end when we picked up. That's the only place where we picked up. It's a good chance we released before, but we definitely released after 30 minutes. But, you know, maybe we released after a couple of minutes. And then again, if we are looking at here, you know, we conservatively we used 30 minutes here on the successful release attempt. And, you know, comparing that to drop 1 or 2 hours with dropping a ball, it is definitely a potential of saving time here as well.
I think as well, this, you know, pulls the liner hanger company into this equation as well, because, you know, we're providing valuable data for them, for the operator, for NOV, and for deep casing tools.
Yeah, I like, you know, we will come with a customer statement at the end here, but I would also like to focus on, you know, we are one big team trying to get better, and with all the service providers on the string, right? So, you know, the liner hanger providers, if you have screens here, you know, completion packers, you know, everybody will, you know, gain the benefits of having downhole data. It's almost like having a, you know, pulse data when you are doing your training nowadays, right? It just helps. No downside, it only helps.
Absolutely. And I'll let you guys read through the testimonial. This was the senior completion man that was on the rig. We were supporting him remotely from our bases in Norway and in Aberdeen. A very nice review. And we do feel part of a very big team working with this operator. They've had the benefits, and we've all had the benefits. And it's very much a team collaboration, and something that we will be looking to continue in the coming months and years. So, Emma, just do you want to please share the results of that second and last poll, please?
Yeah, thanks, Ian. So another overwhelming yes from everyone who answered the poll. Everyone answered yes to that one as well.
That's what I like to hear. So it's whether this data would be even more useful in real time when running your operation, and that kind of brings us nicely, Kim, to the rough forward plan for this field and for our tools.
Yeah. So historically, if we go back to the downhole data tool, one of the first questions our reps always get, memory is fine, it's beautiful, it will add a lot, but real time, that's the golden egg. That's making changes on the ongoing well, real time. That will be, and you can imagine everything we have discussed here in real time instead of learning afterwards. Just a recent example where we had 3 attempts, real-time data would just help us straight on. And real-time, we have a solution right with that as well. So NOV purchased our Norwegian company in 2016, and they have a technology called wired drill pipe. So we use that as a platform to transfer real-time or data real-time from downhole to up, and via drill pipe, that's more or less just a drill pipe with a physical wire inside each drill pipe and then a coil in each connection. So I'm happy to talk about that. We have written SPE papers about the tool and the platform, about how it's set up as well.
Well, that takes you on nicely to the first question, Kim. It's do you have any case histories or SPE papers describing the tool used in conjunction or standalone?
Yes, yeah. We have several SPE papers of the Icon memories, both here in the North Sea, and also we have from Africa with Total. We have with Hess here in the North Sea. We also have one SPE article with the Icon real-time version also. That's, I guess, the newest one. And then we have, I guess, Ian, one baby in the oven here as well. We are writing one SPE paper with this combined, where we are using downhole data with drill pipe swivel, and we also have the operator on board on that one. So that's the one. So look out for that one. I think it will be an interesting one.
Yeah, definitely. No, good shout. And looking forward to seeing the end result of that. And I believe we're also getting an article published in the Operators magazine as well.
Correct.
Second question, how much time did the client save by doing a mechanical release? We'll cover this slightly on the second well. And especially on a multilateral well, if we're spending 2 hours doing hydraulic set and release per lateral, total of 6 hours, and we manage to do it in, say, 20 to 30 minutes per lateral mechanically, we're going to save about 4.5 hours rig time over the course of the 3 laterals. Now, as we mentioned before, rig rates are $400-500 US, $1,000 US a day, and that is, a 6 of a day's rig time. You're probably going to save about 100,000 US very easily by using this. One more question coming in. Do you think we have a MechLOK solution for all potential applications? And I'd say we're largely covered these days with the development of the 3 new styles with this customer and the original tool. and the fact that we have designed the tool in such a way where it just requires adapter kits rather than full tools. We can just change one configuration to the other. It means it's not just a one size fits all for our customers. You know, we give them the best tool for the job, and we work with our customers to provide sort of like tailored engineering solutions. And I think we've demonstrated that very well over the course of the last 18 months with this customer in Norway.
Yeah, I think on the tool size, you have two sizes, right, with the MechLOK.
Yes.
But not all the versions are available in each size.
All of them except the
Yeah.
R in small size.
Yeah, thanks.
Which will come.
Yeah. Well, that was my next question, actually.
Fantastic. But yeah, any further questions, guys? Anything you want to put in the Q&A? Okay, if not, if I got
I see we have a couple of ones here.
Oh yeah, okay.
Yeah.
Yeah, any case history for MechLOK in the Middle East? Interesting. Okay, so yeah, we also have a tool in hole in the Middle East right now, with a major operator in Abu Dhabi. That well is ongoing. We have so far managed to gain the customer an extra 5,000 feet of depth by swiveling. Unfortunately, there is not an icon on this job, but that would be our third job in the region, and will hopefully lead to us being fully qualified to go and operate across all assets. Now, these tools are offered on a rental basis with a run charge. Icon largely the same. I think if there was a certain market that required a sale, we would look at it, but for all intents and purposes, these are rental tools, and I'm sure Kim agrees.
Yeah. This is one of the questions we got earlier as well, and we have clients asking for this as well, and for now, I'm answering on behalf of Icon though. We have only done rental jobs, and we are short-term, long-term rentals, and we are open to discuss, selling tools as well. But it's a huge question these guys are asking, because at least on Icon we have lithium batteries, and some of these redresses, and we're talking recalibration, they are not easy. Redress is easy. Recalibration, I would say, is opposite. So it's possible to do a sale, definitely, but it may be required some kind of planning and dedication from these teams who are buying these tools as well. If we not are doing that, so they can buy a tool and then send them for redressing, the calibration, etc.
And from our perspective as well, we've got tools placed strategically around the world now. We've done jobs now in the UK, Norway, India, UAE, Malaysia, Australia, New Zealand. So we've got a pretty wide geographical scope, and we have tools placed strategically across the world. So for any local specific markets, please get in touch with us, and we'll advise where our nearest stocking point is. So yeah.
I guess it's the same with NOV being a global company. We are set up with offices, workshops around the globe. We have done jobs in most continents, right? And it's easy to do business. Typically, we have contracts set up already globally.
Nice one. All right. Well, I think we'll round it off there, everybody. I'd just like to thank you all for taking the time to come and listen to us. I know we're very excited about what our partnership holds in the future. Considering what we've done to date, there's got to be more exciting things for us to do in the future with this operator and with others in different countries, different markets. So if there's any questions you would like to ask out with this forum, you'll find our contact details on LinkedIn. So please do get in touch, and all the best, everyone, and thank you once again. We'll speak to you all later.
Thank you.
Goodbye.
Goodbye.